This is the foundation level tutorial for learning the FM synthesis and the DX series synthesizers. The focus is on the algorithm interchangeability. This tutorial will go into the next level of understanding algorithms. Before starting this tutorial, there are a few things that you need to know and do. For those new to the FM synthesis and the DX series synthesizers, you should complete my tutorial for beginners so you have the basic understanding of the FM synthesis. You need to know a bit about the DX7 or software FM synthesizers to navigate its menus and find parameters that you need to see. Please make sure that you have the original DX7 Voice ROM 1 and 2 patches. You will be using them as examples. As you need to concentrate on learning, please find a quiet place. Once you've done everything, then you are ready to go. So what benefits you will get? You will benefit from learning the algorithm interchangeability. This is so critical as you will equip yourself with knowledge and skills to expand your understanding of the FM synthesis. By learning all of that, you will have FM knowledge and skills that you can apply to other FM synthesizers, such as software FM synthesizers. Before I will go into detail, I will quickly go over algorithm. As I mentioned in my first tutorial, algorithm is the most important aspect of the DX7 FM synthesis and other FM synthesizers. As we've learned, algorithms determine how all 6 operators interact with each other. There are 32 algorithms for the DX7 Mark 1 and 2, and they are grouped into 4 major groups. So why are they important? They are important because determining an appropriate algorithm is a key to creating a patch that you want. So we have 4 groups of algorithms printed on the DX7 front panel. But the original grouping is too limited for understanding algorithms better. So why is that? Because we have to look beyond those 4 algorithm groups and find similar algorithms. Our ability to see and recognize similarities and differences of algorithms is critical to understand the algorithm interchangeability. What I mean by the algorithm interchangeability is that those algorithms are quite easily swapped to one another for providing varying levels of frequency modulation as well as additive synthesis. For example, which algorithms are similar to algorithms 1 and 2? Let's pause here for a few minutes and try finding algorithms that are very similar. Once you've identified, let's compare your finding against my finding. Algorithms 1 and 2 are similar to algorithms 14, 15, and 18. I call them stacking and branching combination group 1. They all have 3 or 4 operators stacked top of one another. Let's look at those algorithms in detail. Algorithms 1, 2, 14, and 15 have 2 towers. The first tower is made up of 2 operators. The second tower is made up of either 3 or 4 operators stacked on top of one another. Note that algorithm 1 and algorithm 2 have feedback loop on different operators. Algorithm 1 has it on operator 6. Algorithm 2 has it on operator 2. The same feedback loop swapping is also seen on algorithms 14 and 15. As explained in the previous tutorial, Sound Design, Tube Bells, Part 1, a feedback loop adds higher harmonics to an operator without requiring many of them. Usually, it's used for generating a sawtooth wave just using operators 1 and 2. Also, between two towers, the additive synthesis is applied to mix those two towers to create an overall sound. Some of you may notice that I included algorithm 18 in this group. The reason is that it has a pseudo tower with 4 operators stacking, like algorithms 1 and 2. The reason why I call it a pseudo tower is that instead of each tower having on its own carrier operator 1 is shared by 3 operators, operators 2, 3, and 4. So operators 1 and 2 are pseudo tower 1. Operators 1 and 3 are pseudo tower 2. Operators 1, 4, 5, and 6 are pseudo tower 3. As there is no independent and separated tower in algorithm 18, there is no additive synthesis applied here. This algorithm is a pure frequency modulation algorithm, converging all FM outputs into operator 1. So, why am I doing this exercise of algorithm interchangeability and teaching you how to recognize the interchangeability? This is the most critical and powerful knowledge and skills in learning the FM synthesis. I've learned this in a hard way, spending many years with my DX7 making awful and failed patches. Now, you can learn this most critical step up front. Yes, you're very lucky indeed. As we now know, algorithm is the most important and the first step in the FM synthesis. When you want to make a patch, you need to have some ideas of which algorithms you want to use, because you need to determine how each operator interact with each other, either by frequency modulation or additive synthesis. You have to select an algorithm no matter what you do with your FM synthesis. Then, you can try several variations of a patch using interchangeable algorithms. Because you just never know which one works the best. Plus, you have options to expand your patch making by using interchangeable algorithms. For some, this may be counterintuitive, because you have to plan ahead for making a particular sound. For analog and subtractive synthesizers with filters, you just tweak knobs and you get an instant result with no planning, but just randomly changing filters, etc. But for learning the FM synthesis, this is a great way to start your journey. I think a lot of thoughts were put into creating and selecting those algorithms by Japanese engineers at Yamaha, during the development of the Yamaha DX7 Mark I in the early 80s. They are not too many, not too few, but just right amount and right variety. They gave us many options to try and use those algorithms. The second one is stacking and branching combination group 2. They are algorithms 3, 4, 10, 11, 16, and 17, and they all have 3 operators stacked on top of each other. Those algorithms include one tower with 3 operators stacked on top of one another. For algorithms 3, 4, 10, and 11, they all have operators 1, 2, and 3 stacked. A minor difference is the location of feedback loop. For algorithms 16 and 17, they can have 3 pseudo towers, like algorithm 18. Pseudo tower 1 is made up of operators 1 and 2. Pseudo tower 2 is made up of operators 1, 3, and 4. Pseudo tower 3 is made up from operators 1, 5, and 6. Again, like algorithm 18, they are pure frequency modulation algorithms with no additive synthesis. The third one is stacking and branching combination group 3. They all have 2 operators stacked with or without branching. These algorithms have the first tower with operators 1 and 2 stacked on top of each other, with a minor difference of the location of feedback loop. The second tower is made up of operators 3 and 4 stacked on top of each other, with a branch which is made up of operators 5 and 6. Note that algorithms 5 and 6 have 3 towers. For algorithms 7, 8, and 9, they have 2 towers. On their operator 3, there are 2 branches with operators 4 and 5. Operator 6 is stacked on top of operator 5. This means that you can pack higher harmonics with 3 operator stacking of operators 3, 5, and 6. For algorithms 12 and 13, they have 2 towers. On their operator 3, there are 3 branches with operators 4, 5, and 6. The fourth one is routing and branching combination group 1. This group includes algorithms 20, 21, 26, and 27. This group is a variation of algorithm 20, which has routing with operators 1, 2, and 3, and branching with operators 4, 5, and 6. When you look at algorithm 21, it has the same routing with algorithm 20. For algorithm 26, branching with operators 4, 5, and 6 is similar to algorithm 20, except for the location of feedback loop. For algorithm 27, branching is the same with algorithm 20, without a feedback loop on operator 6. The fifth one is routing group 1, which includes algorithms 22, 23, 24, and 25. They all have 3 or 4 operators routing. If you look at algorithm 22, routing is made up from operators 3, 4, 5, and 6 with a feedback loop on operator 6. If we only include routing with operators 4, 5, and 6, then this routing applies to all algorithms 23, 24, and 25. Note that for algorithms 24 and 25, there are 2 or 3 operators without modulators. They are carrier-only operators which produce pure sine waves. When you have towers, branches, and roots with carriers as well as carrier-only operators, the additive synthesis is used to mix those operator tones. Now, what I want to stress is that this is just an example. If you can, you should come up with your own so that you can expand your understanding further. Now, it's a good time to revise what we've learned so far. As we went beyond the original algorithm grouping, it helped us to understand the algorithm interchangeability much better. As we saw from examples in this tutorial, each algorithm can be interchanged quite easily with different algorithms. And I encourage everyone to be creative and find your own interchangeable algorithms. Finally, and most importantly, by understanding the interchangeability of algorithms, it helps us to choose right algorithms and explore more possibilities. You can pause here and do self-learning. From the factory patches, choose some patches and learn which algorithm is used for each patch. Go to an edit mode for the DX7 or just look for algorithm in software FM synthesizers. You can turn on and off each operator and see which operator is making particular harmonics or inharmonics. Finally, you should try to come up with your own grouping of algorithms and think about more options and possibilities. If you haven't done so, please subscribe to my channel, Power DX7, for more DX7 demos and tutorials. The next tutorial will be the FM synthesis, sound design, tube belts, improvement, part 2.